Hi everyone, it's me, Carolyn, and this video we are going to talk about section 1.6. In this section, we are going to be looking closer at the designed experiments way of doing a study. Remember, we had two types of studies. We had an observational study and a designed study, which is more like a designed experiment. And so we're going to look a little bit further at that. Again, we are just touching the surface of these things. They can be as complicated as Gödel or very simple. But we're just going to look at a few different types of things and just get your feet wet so you can kind of know what's kind of in the background when you're reading some of your information that you'll be getting when you get in the real world. So I'm going to share my screen as usual. And we'll look at our guided notes, which are available to you as well. So curtain here so it's not so dark. There we go. And again, this is section 1.6 and some of the terminology that goes with it. So in designed experiments, we talk about this word treatment. Now, the treatment is the thing that we do to our subjects. Now, it might be one treatment. You may be just giving one drug, or you might be giving different various drugs, or it might be as simple as, I don't know, just number of study hours. Maybe you had someone sleep this long and you might have had somebody sleep that long. If you're trying to figure out, does sleep affect how we do on things? Does a nap, how long is a nap? People having different lengths of naps. So treatment is just what we are doing to our subjects. And again, subjects could be people or it could be things. So just remember that it is not always people that we are doing these experiments on. We can be doing them on plants. And I'll do an example later on about using plants. An experimental unit, well, that's the subject. That's the person or the thing that we're doing this stuff to. Sometimes we will have what we call a control group. And a lot of times we will want to have some sort of control group. And the control group is the people or the things that don't get anything but what is normally done. So if this is like cancer study and we're trying to test out a new drug, the control group would get the current treatment process, whatever that happens to be at the time. And then we'd have other groups that would get these other treatments. So we can kind of compare to see if there is any change with these new pieces. A placebo is another term that is sometimes used as in this information, and a placebo is like a fake treatment or a sugar pill, so to speak. So if the status quo is to not get anything, we want to make sure that this control group doesn't know that they're the control group. You know what I mean? We don't want them to say, oh, I'm not getting anything, so I'm not going to get better kind of feeling. We want to make sure that everybody feels like they're in the same boat. So a lot of times we will give a fake treatment to these people. And we want to kind of rule out this placebo effect where people say, oh, I'm getting a drug, so I must be getting better. Because the mind can cause things to happen. I mean, sometimes you can will yourself to get better. That's what this placebo effect means, is basically you're given the sugar pill, but for some reason you're still getting better, although you've got no treatment for that, whatever it happens to be. Sometimes we'll have what we call is a single blind. A single blind experiment is when the subjects, people who we're doing these things to, don't know what they're getting. So if there's different levels, they just know they're getting something. Okay, they don't know if they're getting the placebo. They don't know if they're getting 5 milliliters. They don't know if they're on the 10 milliliters. They don't know if they're getting drug A versus drug B versus drug C. So that is a single blind. The double blind is the people who are administering these treatments also don't know what treatment is given. So they're just given the empty the pill, so to speak. They don't know if this is the 5 millimeter, the 10 millimeter, or whatever, because they all look the same, and so forth. So, and this is the reason for this is they want to make sure that administrators, if they start to see changes in some people, if they know that these people are getting a certain drug, they might be more inclined to push that certain drug or give that certain drug to others as well, which can throw off the study. So we want to make sure that the administrators sometimes also don't know. There is always someone who knows to make sure that the data is collected completely, but that would be kind of in some place in the background, but it's not going to be the person that is up front with these subjects. Okay, so that would be a double blind. All right, there are some steps when you are designing an experiment, and this is also the same steps that you would see in a biology class or a chemistry class or something of any nature where you're designing some sort of experiment. The first thing you're going to want to do is to identify the problem. It might not be a problem, but you might want to identify what you want to do. We want to increase the success rate for cancer patients, or we want to increase the corn yield on our fields. We want to increase the speed at which this machine works, or we want to decrease the number of errors a student makes. Any of these problems things that we want to change. Then what we're going to do is we're going to try to determine the factors that affect this response variable. So, for example, the number of corn, what goes into corn production or corn rate, or what happened, how can we help students perform better, or how can we have better cancer results? So some of the factors that go into it. So the drugs that they're being used, the water we're giving people, the amount of sleep you're getting, or the amount of study time you're doing. The next thing we're going to do is determine the number of units that we need. How many people do we need in this study? Do we need 17? Do we need 30? Do we need 1,000? Because based on what we want to do. So, I mean, if we're testing out 7 new different drugs, we want to make sure to have enough in each of those categories. So that's where this comes in. And then we go and gather those people. We're also going to determine the levels. Do we have our control group? Do we have randomized pieces? How are we going to put this all together? Okay, so we kind of get all the planning done ahead of time, and then we go and actually get our people, and we actually do the data, do the experiment, replicate it if we want to. Sometimes there's a replication, we might want to do it again. Do it in this year, do it next year, do it years down the road, because we don't want to just judge everything on one trial. Maybe we want to do this trial a couple of times. We want to collect all of our data. We want to process our data. And then at the very last thing is we want to test to see what actually happened. Did we get results that we were looking for? Or do we have to try something else? So kind of look at that way. And we will look at testing a claim a little bit later in some of the later chapters. Again, we just touch on these ideas just to give you a taste of what happens out there. All right, there are a couple different types of designed experiments. There are a lot more different ways of doing things than what is done, the 3 that we have listed here. And sometimes there's mixing of the 2 and so forth. So one method is a completely randomized design. A person comes in, they're randomly given the treatment. There's no, just completely random. Your person A, you get drug A. Your person B, you get drug B. Your person C, you get drug C. And they just have some sort of random method of doing so. A matched pairs design, the subjects are matched up just to kind of have some sort of similarity in the people, but differences in the treatment. So there's a couple different methods here. One is to match people up with somebody else. So if you're doing something like a test on people and you're trying to see does sleep matter on performance on exams, you're going to try to probably pair people up with similar IQs. So I'd be paired up with someone with an IQ. I would have one treatment, they would have another treatment. So they could compare us together. You might have two females, you might have two males, if there were certain things that the gender of a person may affect. So you want to be able to compare what happens in a female of this nature versus a female of the same nature. So kind of looking at a situation that way. Another matched pair design is when you are you're paired with yourself. And sometimes that is on a test and a retest. So it's like you're given something first time and then it's kind of like a pre-test, post-test. Or if you're trying to find out if you're better with a certain, I don't know, there's like golf clubs. Maybe you're testing out two different golf clubs. So you try one golf club versus another golf club. And the randomness would be in which one you do first. You know, they flip a coin and they say, okay, use this one. And they flip a coin and they say, okay, use this one. Or maybe you're testing out golf balls. You know, here's this ball, here's that ball, here's a different ball. You now hit them. And they would have the person is matched with themselves. So you'd be comparing how you do on the three different treatments or however many treatments there are. Okay. A randomized block design is a little bit more structured. We're going to be divided into groups, similar groups. So there'd be one group A and group B. So if I had two possible stats courses, you guys would be maybe similar in nature if that happened. And then I could test randomly within the two groups. So maybe I was checking to see if a certain project versus a test, which one would you guys perform better on? So I'd get some people the test, some people the projects in both of these groups, and then I could compare. This is kind of done a lot of times in plant growth. So for example, corn, they will take a block, basically a field. So you may have different fields on your farm. And within these blocks, they will test different fertilizers. So they may have 6 fertilizers have this type of, or 6 rows have this type of fertilizer. And then the next 6 rows might be nothing. And then you might have another 6 rows with a different fertilizer. And then the ones that didn't have fertilizer, that would be that control group, so to speak. Or they might be testing different seeds to see if this seed grows better than this seed. Does this seed grow have more production than this seed or under the same conditions, where the field is that block and a different field maybe on the other side of the road could be a different block. So we're kind of have more than one block and within those randomly assigning those treatments. So those are just 3 of the design types of experiments that are kind of we're going to touch on. Again, we're just looking at these things, getting familiarized with what they are and so on, so that when you read results of experiments and things like that, you can start asking yourselves questions like, how many people did they do this on? What kind of design did they say? Was it completely randomized? Was it this? Because asking the questions and scrutinizing the data is something that people sometimes don't do. A lot of times we will just take data for face value and we blindly accept it. I think in the world, we need to start being a little bit more critical of some of the information that we're given, because one person will tell us this thing and another person will tell us the complete opposite, where we need to kind of maybe be smart enough to analyze and critically ask those questions. What did they do? How did they do this? How many people? How long did they study it for? What was the control group? You know, was it a single blind? Was it a double blind? Did they use a placebo? All of those kinds of questions you want to start asking because you'll start being a little bit more better informed, and you'll be able to kind of weed through some of that nonsense information. Well, this kind of wraps up chapter 1. It's full of lots of information, not a lot of stuff to do. So just kind of getting ourselves acquainted with the terminology and the way that statistics works. So we're going to be moving on to chapter 2. And chapter 2 is all about graphing and how we display our data. In that section, we'll see some graphs that you're familiar with, and then we'll also see some that you're less familiar with, or some that you may have never seen before, but they do have their uses. But that's chapter 2. So I'll see you in the next video. Again, if you have any questions, feel free to email me, and I'll talk to you guys all later.